Thank you. First of all, welcome to presentation on BigQuery Omni and how it changes the landscape of multi-cloud data analytics. This is more of an introductory presentation on BigQuery Omni, but I hope that it will provide you some value. First, I'd like to thank you for attending the meeting and taking the time out of your busy schedule. I know everybody's got a lot to do, but thank you for giving us time and attention. I also want to thank Ron for organizing Angelbeat and giving Redapt and myself an opportunity to connect with you. As Ron mentioned, Redapt is an end-to-end technology solutions provider. We're focused on helping businesses navigate complex challenges to compete in and lead their industries. From bare metal to cloud, we're a one-stop shop for all your enterprise IT needs. A little bit about me and where my background is and why I'm here today. I'm lead GCP and AWS architect on our advanced analytics team. I have a specialty in BigQuery. So I want to have a conversation about BigQuery first before we get started, just so that everybody's on the same playing field. Some of you may know BigQuery, some of you may not even know that it exists, but what is BigQuery? BigQuery is Google's enterprise data analytics solution. It's fully managed, it's serverless, it's capable of querying petabytes of data in very short order. You can see on the screen all of the aspects that can be found within Google BigQuery. I'm not going to bore you by reading the screen, but definitely it's a solution that provides high-speed analytics. There's machine learning built in, and it even can ingest streaming data and provide insights and streaming data. That's all fine and good, but what makes it different? And in this particular instance, the architecture is what makes BigQuery different. High-level overview of the architecture of BigQuery. The key point that I want to address today is that storage is separate from compute. And this is one of the primary things that makes BigQuery different. They're completely decoupled, they scale independently, and they scale on demand. This particular architecture is exactly what makes BigQuery Omni possible. So I want you to keep in mind this architecture so that when I refer back to it later on in my presentation, you'll have a better context of how BigQuery Omni is related to this. So before we get there, though, let's talk about why we should be worried about multi-cloud queries. I mean, after all, if I'm on Google Cloud, shouldn't that be my focus? Shouldn't I be on Google Cloud? Well, the reality is that's not the case. And multi-cloud is here to stay. According to Flexera's 2021 State of the Cloud, 72% of their respondents are in a multi-public cloud implementation. And even in hybrid cloud environments, and this is the respondents here, the respondent results here from the hybrid cloud, over 76% of the hybrid cloud implementations identified here with blue are in multiple public clouds or multiple private clouds or multiple public clouds and one private cloud. So this is a reality. How do we manage this landscape then? First of all, let's ask, why would I do this? Why would an organization do this? Well, the number one reason this is the case is optimization by workload. Some clouds are better at other things than another cloud. And so I may have a workload that's best if it's on Azure. I may have a workload that's best if it's in AWS. So so organizations choose workloads based on the best cloud solution for that. Multi-cloud also provides a bulwark against vendor lock-in. If all my eggs are in the AWS basket, I'm reliant on AWS, and I'm reliant on AWS's business model. That affects my business model. It also can be used to improve uptime. So you can have failovers. You can segregate your traffic and push it to different sides of the cloud in order to leverage multiple clouds. You can reduce latency. Public clouds do a great job of hitting the major areas, but your customer base might actually exist in a region that's not served by one of the clouds. And so you might use another cloud to bridge that gap. And lastly, and this is a case where I see a lot of multi-cloud implementations, is legacy applications. We have instances where Google has made a big pitch to a client. That client comes in and they do their greenfield development in Google Cloud, but are really reticent to move their legacy applications from their other cloud into Google Cloud. It works there, so why would we change it, right? And so there's a trust issue, and they've got to build trust in the one cloud before they can actually begin to move their enterprise solutions to a new cloud. So these are some reasons why you might have a multi-cloud environment in place. When you have a multi-cloud environment, it comes with challenges. The more distributed your cloud solutions, the more challenges you have with your governance plane. So now I have to have governance in Google Cloud, and I have to have governance in Azure or AWS. Creating a cohesive solution architecture is also more difficult. How do I make sure that the applications that are being developed in Google Cloud work seamlessly with what we've got in place in AWS, for example? Managing cost becomes a challenge, particularly because if you've ever gone and looked at the cloud costs for any one of the solution providers, they aren't the same across the spectrum. It's very difficult to go and say an apples for apple comparison. There's always this hedging. Well, this is sort of what it looks like on Google Cloud if we were to put it on AWS. So even having a apples to apples understanding of what the cost becomes a challenge. Data protection becomes a challenge. If you've got your data is spread around, it's also more difficult to identify who has access, manage that control. Skill set coverage is a major challenge, especially in today's world where we have such a shortage of high-value skilled employees. Now if I have 3 clouds, now I have to either ask my current employees to have the skill set coverage for 3 clouds, or I'm hiring 3 different sets of employees from my pool. And then you've got multiple divergent data sources. How do you make good, clear analytics decisions from these multiple divergent data sources? Now, I'm not going to tell you that Omni is the magic bullet to solve all of these, but I will talk about how Google Cloud BigQuery Omni actually addresses some of these. So let's just take this is a very simplified visual of what a hybrid cloud, a multi-cloud solution might look like. This is just for demonstration purposes. Please don't tear it apart as far as logistics. But in this instance, here we've got mobile data coming into the Google Cloud. Cloud Spanner is picking that is the storage engine for this, and we're doing very simple data analytics with Data Studio on this. And then we've got delivery data coming into Databricks. It's being ETL'd, stored in Parquet files on Azure Data Lake, and then Power BI is the tool that's being used to visualize that data. And then lastly, over here on AWS, we've got IoT device data coming in, streaming into storage on S3, and we're using Amazon QuickSight to look at that data. So this just kind of gives you an idea of what an environment might look like. So in early last year, Google introduced BigQuery Omni, and at Google Next, back in October this year, they announced that it was generally available. So I'm not going to bore you by reading the Google sell sheet description of what BigQuery Omni is, but in a nutshell, what this statement says is you have a single SQL context to access and query data across your public cloud sphere. So how does it do this? Well, let's take a look. I'm going to take you back to our BigQuery architecture overview. I remind you that this is managed, it's serverless, and the compute is separated from storage. So let's look at the implementation of that architecture then in BigQuery Omni. So here we have, this is what we were just looking at, our BigQuery Google Cloud region. Here we've got a BigQuery compute cluster running Dremel, and we've got our BigQuery storage separated from this. Well, what Omni does is essentially the same thing. It instantiates a compute cluster running Dremel within the other public cloud using virtual machines. It uses all of the inherited APIs within that cloud to access the customer's S3 storage. So again, here, compute is separated from storage. So if we were to take a query in action, end user submits a query. That query is sent to the BigQuery control plane, and that control plane checks the query, creates metadata, moves it on to the BigQuery routers. And the BigQuery routers then look at that query, identify the end source, the end location for that. What data plane do I need to send that to? If it's a native BigQuery, it'll send it to BigQuery. If it's going to one of the public clouds, the other public clouds, it will send it out that direction. And so here we have that query arrives now on the AWS data plane into that cluster, and that cluster then begins to process that query. That query then reaches in to the cloud storage, begins its analysis, does the query, brings the results back to the data plane, which then sends it either back to the BigQuery routers or can store the output of that query directly back in the localized storage. Regardless of whether the query results in the data results go back to BigQuery or are stored locally, the metadata results of that query are sent back to the control plane and delivered back to the user. So here we have a full round trip of a query, simplified, of course. There's a whole lot more details under the hood, and be happy to have a conversation with you if you'd like. So, oh great, Chris, you just showed me what it looks like in the AWS environment. It's got to be way more complex to do that in Azure. No, it's not. You can see here, because of the way that Omni is implemented, it's the exact same infrastructure, whether it's in AWS or it's in Azure. So in Azure, we're bouncing up a VM cluster, accessing storage on the ADLS, and pulling the data in, running the queries locally, and returning the results. So in the end, our diagram from earlier changes to something more like this. So here we are, we're addressing governance because now our control plane is in one place. We've got a control plane right here. We can say what IAM users, what IAM roles have access to what data, and this can be done down to the column and row. We have a cohesive solution to our architecture. All of these other aspects of the public cloud can happen behind the scenes. Your IT people can manage it, but you notice here, over here, your users have a single instance that they're reaching into to grab data. We also have data protection. BigQuery offers a significant level of data protection. Again, like I mentioned, down to the row and column, you can actually identify a column that user can see, but they can't actually query the data from. Also reduces your skill set coverage. Whether or not I know Data Studio, Power BI, or QuickSight, I have a single SQL context for making my analytics. And then here we can see that our multiple divergent data sources are coming into one single plane for our analytics. It sounds all great, Chris. What are the things I need to know? Well, first of all, there's no on-premise implementation of Omni yet. So if you have an on-premise data warehouse that you want to be pulling into your BigQuery queries, that's not part of the plan at the moment. Cloud joins right now are only in alpha. So if we were to take our example of our mobile data and our IoT data, those queries would have to be run separately. There's no join between those two queries. That's in alpha right now. I can't give you a timeline on when that would be available. So visualizing that would be required. You'd have to work with your visualization tool to see how that to make that connection. It's also important to note you can only connect to external tables, so CSV, JSON, Parquet, or Avro. There's also limited regions where AWS and Azure are actually capable of running BigQuery Omni. It does require slot commitment, and this is one of the surprises you might find is there's slot commitment, and there's also on-demand querying. So on-demand querying is you pay for the query cost, whereas flat rate pricing with a slot commitment or a flex slot is you say, I'm buying this amount of query resource. And so in order to run Omni, you have to buy this set of query resources. And so then you raise your hand like, ooh, what are the costs for this, Chris? Well, if your query with your results are exported to the cloud where they occurred, there is no additional costs for making that query. It's all the costs for that reside with the cloud that you ran it in. The question about compute always comes up. That's why there's flat rate, or that's why there's the commitment. Your commitment is the cost for that compute. So when you pay Google for the flat rate or the flex slots, that's how Google is paying for the VMs on that environment. And then, of course, based on whether the mechanisms and or the destination of your data, ingress or egress of the data may incur costs. So this is, like I said, a generalized overview of what Omni provides us in the multi-cloud environment. And I hope that it's brought you some value. And I'm certainly open to answer any questions. Here's my contact information again. And I've also included contact information for Andreas Schreiber. He's our Google Cloud Head of Sales. So feel free to reach out to him as well. But I'm happy to entertain questions.